Alright, taking a look at problem 4-97. We have our parent function for a parabola, y equals x squared. And we know that it has an x-coordinate of -4. So y equals a -4 squared. So that means y is positive 16. That gives me a coordinate point of -4, 16. That is on that graph. I also know that it has an x-coordinate of 2. So y equals 2 squared, which is 4. Give me the coordinate point of 2, 4. So for this problem, the line is going to intersect the parabola at these 2 points. So if we make a graph of that, our parent function is going to look something like this. And our last point here is up here at 416, or -416, and positive 416. So there is our parabola. At this point up here, and at 2, 4, that's the line. And I want to find the equation of that line. So I'm going to make a slope triangle. So from this point up here, if I want to go from that point to the other point, I'm going to go down. I'm going to go down from 16 down to 4. That's a total of 12. So I'm going down 12, which is actually a -12. And then I'm going to go to the right. And I'm going to go to the right from -4 to positive 2. Which is going to be a -6. So my slope triangle here gives me a slope. Oh, this is positive 12. My slope triangle is giving me a slope of -2. So now I take y equals positive 12 over a -6 times x plus b. I'm going to take one of these coordinate points and substitute it in for my x and y values. So I'll use this coordinate point again right here, which again is 2, 4. So when I substitute that in, I have my y value of 4 equals my slope, which reduced down to -2, times my x value plus b. And I solve for the y-intercept. So 4 equals -4 plus b, and b equals positive 8. So the equation of this line is then y equals -2x plus 8. That is the equation of the line. The second part of this problem is asking about the measure the angle makes with the x-axis. So again, if we look at our graph, we know we have a slope of -2. So if I would focus in on just this part of it right here, let's say a slope triangle there. So my slope triangle has a side length of 2 and a side length of 1, because again it's a slope of 2. And I want to figure out this angle theta. So for that, this is going to be a tangent problem, because I'm dealing with the opposite and the adjacent legs. Tangent of theta will equal 2 over 1. I know this is originally a -2, but when we're dealing with slope triangles, we're just going to use the positive side of that. So to solve for theta, I'm going to use the inverse tangent function. And theta is going to be approximately, when I type that in my calculator, 63.435 degrees. And there we go.